Alright, so welcome everyone to the second Golang lecture. I'm glad you were able to attend both the first and second lectures. So essentially today we're going to be going over a lot of the things we went over last week in our previous lecture, lecture 1. And we're also going to be extending that into talking about some more complicated features in regards to mostly just lists, arrays, slices, maps, and then also some for loops, which are iterable items. It's going to be a pretty simple lecture. I'm only planning on the lecture being about 60 minutes long. And then for this week, we will have homework, though. Last week, the content was pretty simple, so I didn't assign any homework. But this week, we will have homework. So we can go ahead and get started. So if you remember the project structure, I'll make sure I'm focused on the Go question. Sorry about that. So we can go ahead and get started. So basically, if you remember the project structure, we have this package main. And we're going to always be using package main for the sake of this class mostly, and then we'll get into submodules later. And then, as always, we're going to be importing FMT. And one thing I want to point out is that if you run this code, Golang by default is going to make sure that you're using everything you import. This is so that it's not importing code it doesn't actually need. Importing code that you're not actually using is actually bad practice. So, it's going to go ahead and require you to use everything that you import. So, for example, in this code, even though it doesn't do anything, it doesn't want me to use package FMT. So if I delete it, I actually just comment it out, and if I hit run, then it'll go ahead and let me run this program. It's not going to do anything, but it'll let me run the program at least. So that's just something I wanted to point out. But however, we will be using the FMT package. Remember, this is just the format package. And if you have any questions, please ask in the Go Questions channel. So we can go ahead and get started with talking about some of the things that we're going to be discussing today. So the first thing I want to talk about is arrays or lists. So if you've ever programmed before, you'll know that arrays and lists or whatever are very essential parts of any programming language. So for example, in Python, they're pretty simple. They look like just normal arrays. They're followed with a bracket on the right side, another bracket on the left side, and then you have all your numbers in between. Similarly, in the thing in Python, and I'm talking about Python for comparison's sake, you can also put names, like let's say James and Alex. You can put names also in your in this array. So there are a lot of differences between Golang and Python, obviously, but this is generally what an array is. It's a list of items, and you can index them and whatnot. So we're going to start off with the most basic version of an array. And we can go ahead and discuss that. So basically, let's say I want to make an array called grade. So I want to have an array, and all my grades will be in this array. And I don't actually have any grades, but let's just hypothetically say. So what we're going to do is we're actually going to say, the way that we define our array isn't by doing something like this. So this is not a valid way of defining an array. So, let's say that my values were like 92, 99, etc. This is not the valid way to define an array. Rather, what we do is, remember, when you're using this var keyword, the way you define a variable is actually by doing var grades, some var a, and then you define the type after the variable name. So this is the variable name, and let's say it's integer. So remember, a variable named a of type int. So if I print and I say a equals 50, and I run this code, when I run this code, you'll see that it's going to print out 50 because that's the value of a. And that's just a reminder of how this variable name works. So I want to make a distinction here, and rather than using this variable name, the variable type int, we want to define a different type, and it's going to be a list of some numbers. So generally speaking, grades are going to be they're generally going to be integers for the sake of this lecture. However, you can also have floats and whatnot. However, those data types aren't extremely important in terms of Go because it's not really a computation language. But we can also discuss those in just a second. So what I can do here is I can say var grades, and I need to give it a type. So the way you define the type of an array in Golang is going to be basically by using very similar syntax to this, except you're going to put two brackets and then the type of variable that it is. And then within these two brackets, what you're going to type is actually the size of the array. So similar to many other languages, such as C++ and Rust and whatnot, the primitive type of an array, the one that's defined directly by the language, is going to be of a fixed length. So if I type in 5, for example, and then I want to index this. What I can do is I can write all my grades out, and these are not real grades, just for the sake of example. I can write all these grades out, just random grades that I'm picking. So let's say these are your grades, and I'm going to delete this line here. What we can do is we can print out this array as if it was, any other array or any other variable, and it would print out just like that. It's going to print out without commas. Golang doesn't actually use commas when printing out arrays. It's going to print out the grades, in order. And obviously what we can do is specifically we can also talk about a specific index. And remember, in most languages, the array or your list is actually going to be 0 indexed. So when we print out a grade, it's going to be printing out 99, 92, 94, 88, and 90. So this means that and by saying 0 index, what this means is that this is index 0. So it doesn't start counting at 1, 2, 3, 4, 5. It's going to start counting at 0. So it's going to be 0, 1, 2, 3, and 4. So, when you want to index the last value, you're actually going to call 4, even though the length of the array is 5. So it's called a 0 indexed array. And most languages are like that. So I'm going to go ahead and index this. So rather than picking all the grades, I'm going to pick, just one specific index, and I can hit run. And it'll print out just that value. And that's because, the first index, the 0th index, is 99. If I print out, the 4th index, it should print out 90, as you'll see in a second. So that's basically, it's a pretty basic way of writing, an array. So if we wanted to use a different operator instead, so I'll comment out this code here. I don't want to delete the code for the sake of, so you guys can see it. So if I wanted to write the same code but using the preferred type, the preferred assignment operator. Remember, the preferred assignment operator is, in our example where we have var a int equals, var a int and a equals 50. This is the same thing as saying a equals 50, Golang assumes. So, if we print out this, if we print out this and hit run, you'll notice that it's going to print out 50 as, this is the same thing. It's the same, way if you're doing it this method or if you're doing it this method. And something I'd like to point out now is that how do we do this? How do we use this syntax, this assignment operator syntax? And I've been told this looks like a walrus, which is actually pretty accurate. The assignment operator. How do we use the typical syntax that that we're used to for assigning, but using a list? So actually, it's very simple. However, there's a couple, things that might be a little bit different. So since we're calling this specifically an array, what we need to do is we need to also use this type operator here. And this is not like, when you write a number like this, you don't have to say the type. And I'm going to change these to grades real quick. So, we can change this to grades. And I'm sorry for the the other lecturer getting the phone call, but anyways, we can change this to grade, and then we need to change this value to something that actually makes sense. So what we're gonna do in this case is we're gonna say the same syntax as before. So I'll actually just copy this exactly as it is, like that. And if I type this code out and I try to run this code, what you're gonna notice is that it says type 5int is not an expression, and that's because the right side of this assignment operator, the walrus operator, has to actually have an expression. So what we can do is to define all the values, index 1, 0, 1, 2, 3, 4, rather than writing them all on different lines, what we can do is we can define them right here. So 99, 92, 94, 88, and 90. And notice we're using these curly brackets right after this statement. So we're saying that there's an integer array. So there's an array of 5 index, of a length of 5, and it's a defined length. So we can't add more, we can't add less. And then we say it's going to be an integer, and that means the type of every single value will be an integer. And then we can type these values out, and if I print and run this code now, it will print out just like before. It will print out the same thing that I printed out up here. So similarly, I can actually try what happens if we type in another value, and this this index is only length of 5, and we're typing in 6 values. So if we run this code, it's going to say, array index out of bounds. It only goes 0 to 5. And similarly, if I remove 86, now what happens? That's another question that we can ask is what happens when we type in 1 less? If we type in only 4 rather than 5, what happens when we run this code? And you'll notice that it prints it out. However, it just assumes the value is 0. And that's a pretty good distinction, that what we can do actually is we can actually remove all these values. And when we remove all these values, and I'll delete this, or it's okay, yeah. When we delete all these values, it's going to basically use the what's typically known as the 0 value, the nil value, what happens when it's undefined. So in this case, we don't have any defined numbers, so it's just going to print out a bunch of zeros, and it's printing at 5 zeros because we've specified the length of this array to be 5. Okay, so this is the more preferred way of writing these arrays, and then you can also obviously change any of this. So you can change this to float 64. So the data type in Golang isn't actually float, rather it's going to be float 32 or 64. So this means it's a 32-bit number or a 64-bit number. If you're more curious about how these data types work and how like the bit operations work and whatnot, feel free to ask me. I can provide some reading material for you. However, now we can also run this code. It's going to print out something very similar, as expected. It's going to print out a bunch of zeros. However, now we can also type in all these values. I'll copy them from here, paste them in here. If we type these values, it'll also print out just like this. However, now the thing we can change here is that we can also say 99.3 or 99.2, 0.4, 0.6, 0.1, and let's say 89.999. Sure, why not? And if I run this code now, you'll notice that all the decimal places also print out. So if we try the same thing with integers, we're gonna get this. It's gonna say constant 99.2 truncated to integer, etc., etc. And it doesn't like this. It's Golang is generally a very strict language in terms of casting to different variables. And you can definitely cast. However, you can't do it implicitly. You have to explicitly say, I want to treat a float actually as an integer. And a float, remember, is just a number with decimals. So we can change this back to float 64, which is just one of the many data types. Run this code, and it'll print out just like that. So essentially, that's all we have for arrays. And I want to mention that these are arrays by default, and there are very few languages where arrays actually have a unfixed length. So in this language, obviously, you have to define the length when you define the array. And so we're saying that the array is going to be 5 indices long, meaning we can only define 5. You can define less, but then they're still going to have a defined length of 5 indices, and that's going to be assigned to the grades operator. So, and once again, we're using this assignment operator to define this array into the value of grades, if that makes sense. So I'll give you guys a minute or 2 minutes if you have any questions, or if you're working alongside me in your own REPL. If you have any questions about that or how to write this code, then I'll give you a second to figure that out, and then we can move on. Okay, so there's no questions, it seems. So if you have any questions, obviously just feel free to ask, and I'll get to them. So we can actually move on. So we've now figured out how to define arrays using the standard type, which is using the variable keyword, this var. And we've also figured out how to use this walrus operator, the assignment operator, also to define an array. So now I want to discuss, what's the practicality of only having a fixed length array? What if you want to add values and delete values from this array? What if you want to, have 6 values? You realize you want to have 6 values later on in code, but why is your array only limited to 5 values? So we can go ahead and talk about that. So basically, an array is meant to be a very memory and computationally efficient piece of code. So the thing about an array like this is that the length is actually immutable, meaning it can't be changed. And this length not being able to change means you can have the same references to memory no matter what. So if that went up over your head, that's completely fine. Essentially, consider arrays as very memory efficient, very computationally efficient ways of storing data. But there is an alternative, and this is actually an interface on top of the primitive array method, and these are called slices. So we can actually discuss slices, and they're very, very easy compared to these. So basically what I can say is I'm going to comment out this line. And so what I can do to define a slice is actually I'm going to write the same syntax. So grades, equals some length array. We're going to call them we're going to call them ints, or for the sake of this, and we're going to call, and I'm only going to do 3. So I'll change this length to 3. If I don't change the length to 3 and I keep it as 5, you'll actually get 2 zero values. So this will be 0 and this will be 0. For the sake of this, I'll just say this is 3, and I should also remove these decimals. I don't know why I wrote those. So this is going to be an array of length 3, and it's going to have these values. So obviously if I run this code, you're going to see, no surprise here. So we say 90, 99, 92, and 94. So to write a slice, it's actually extremely easy. This is not something, that should come to much surprise. A slice is essentially what we call, it's very similar to a list in Python. It doesn't have any fixed length. So basically the length is undefined. And we can write this very easily basically by just saying that the length of the array has no length. So this is now called a slice. So by not specifying length, this is now a slice. So this is a slice now. I'll move this over. So this is now a slice rather than an array. So if I run this code, nothing will change. What have we just done? We basically turned away the this length term within the bracket, and now it's just the slice rather than an array. So obviously this means nothing to us right now. However, in the background of how Golang processes all the code, you'll actually be seeing that now similar unlike before, now the code actually is going to be treat this as a slice rather than an array. So it's not going to be as memory efficient, and it's not going to be as computationally efficient. However, it does allow us to do a lot more. So for example, if I wanted to append something to this array, and you probably heard the append term thrown around before. In other language, what you do if you wanted to append to grades, you do grades dot append, and then you type in some value. Let's say I have a 4th class, but I only have the 4th class after defining this original array. So I want to add it to the array after the fact. So what you can do is you can actually do that, and you can try to do that. The syntax here is incorrect, but I'll show you how other languages would typically want to do it. So we can do grades dot append. You can type in some grade, let's say an 88. And then we want to print that out. And you're going to actually get an error saying grades.append undefined. And it says type of this array integer. So these two brackets basically mean it's an array. Or sorry, in this case it's a slice. And a type integer. All of the values within grades are integers. And then it has no field or method append. Basically what that means is that we're trying to call the method, this append method, on top of grades. However, that's illegal because that's actually not defined. It's not defined behavior in the language. So what we can do is rather than typing in grades.append, we can actually just say append. It's a function rather than a method. So if we type in append like that, and then we can type in grades like that. So we pass in the list, and then we pass in the value. I'll comment that out. So if we want to append something, we can basically say append. And then the list that we're talking about in this context is grade. That's the list we're talking about here, correct? And then the value that we're talking about, the value that we want to consider is the value which is going to be, let's say 88. That's the value we want to append to the data. So if we try to run this code, we're going to get one more error. And it's going to load. And it's going to say, append evaluated but not used. So the thing is, and actually we can see a little example of this. This doesn't actually do anything on top of grades. It doesn't change the value of grades. So, if I print out, if I, were to, let's say, just say x equals, and I'll have to use the assignment operator. If I try to print that out, just to, get around the error, x declared, oh yeah, I can just ignore the value of the array. Am I? Let me know if it's an issue, but basically, if you have an underscore, it's the value that's actually going to be ignored, because once again, you can't declare variables that you don't actually use, and you can't, have this, random variables and random data just laying around. And that's part of why Golang is so great. It's able to handle this memory so efficiently. So by using an underscore, we're basically asking Golang as a language, hey, just ignore the data that's in this line, and especially now, just for testing purposes, you're going to get something like this. So basically, and of course, the underscore is actually just it's a keyword in Golang, so you're not actually going to have an equal sign or assignment operator. And you'll notice, even though we've tried to append this 88 value to grades, when we print the grades out after this append statement, we're actually getting 99, 92, 94. And this is the same values that we see from line 19, where we originally defined the array. So now you must be wondering, why is this happening, right? So the thing is, this is a function rather than a method. When you say append grades to 88 to grades, it's actually creating a completely new object. So rather than using this old grades object, it's going to create a new object that you'll then have to use. So what we can do is, since variables in Golang are immutable, meaning we can change them, we can actually just say that, let's just say we wanted to say x. So rather than saying, underscore, we're going to say x. So now if I print out both of these arrays, like this, and I run this code, you will notice the first array has 99, 92, and 94, and we're not surprised there. This is the same print statement from before, and we already know that, it's not actually appending to grades. So what is it doing? It's actually appending to this new object, so we're copying the grades array, we're appending this value 88 onto this new array, so now grades by this object yields, let's say, 99, 92, 94, and 88. So this is what it returns. So actually, I'll just use an arrow. This is what it returns, and it pushes this value into whatever this is equal to. So it used to be equal to underscore, and this underscore basically meant it goes into the void. It's automatically garbage collected. It's not actually used. It's useless. The value isn't considered, etc., etc. However, if we actually want to handle the value, we can use x and the assignment operator, because we haven't defined x before. And then when we print out x, it actually does print out 99, 92, 94, and 88 as expected. We're expecting to append 88. And I can do this a bunch of times. I can say, let's say instead of 88, we can do 89, 90, and 91. And we're going to get an error here, so I'll just print this out, and I'll remove this statement here. And I'll print this out real quick. And it says no new variables on the left side of this walrus operator, this assignment operator. And, this is actually very intuitive. It makes sense. We can actually, and if you remember the content from the previous lecture, we're not allowed to use this assignment operator if this variable is already defined. And since x is already defined on line 22, lines 23 to 25 don't actually need it. So what we can do is remove this assignment and just have an equal sign. And now when we run this code, and this is actually an issue. So I have to replace these with the x, and I'll explain that in a second. So now when we do this, it'll have all the values right here, and that's the cool point of this. So rather than using x, we can actually just say grade. So you can replace all these variables with grades, and then all these variables are already grades. And then we'll just change all of these so it doesn't have an equal sign. So it just has one equal sign with no colon. So now when we print this out, and obviously x is not defined, so we'll type in grades here. We now have a way to append multiple values. So we've appended 88, 89, 90, and 91. And we've been able to do that on top of this array as intended. Okay, so this is how you append values to an array. And that's the power of slices. We're able to do something like that. So what we can also try to do is we can use a delete operator. So we can go ahead and talk about that real quick in just a second. And once again, if you have any questions, please feel free to ask in the Go Questions channel. So since these are very mutable, since these are slices, we can actually change the value. And I noticed someone's typing, so I'll just let them finish typing before I go further if anyone has a question. So the return type of an append is actually an array, or a slice, sorry, my bad. It's a slice of the original type. So for example, it's going to actually return whatever type this is. So for example, and the question actually was, what's the return type of an append, right? So what is the, I'll scroll down. What is the return type of append? I'll copy one of these statements, put them down here. So append returns the value, the same type you input. So I want to write this down just so you know you can refer back to it in a couple seconds or minutes or whatever. So the return type of an append, this function, is actually going to be whatever variable type you inputted. So when we input this grades, you'll notice that it's actually a slice, an integer slice. And it's a slice, not an array, because we're not defining the length. So it's going to return the same type. So when we print out this grades back into here, you'll notice it's going to be a grade. And I can show that by just saying, and this is why in the previous lecture we always use the format package, this format package up here, rather than using the primitive print. So if I try to just type in print like this, and I print the grades out, you're going to get a quick error. And I'm doing this intentionally. It's going to say, oh my god, got to comment that out. Now if I run this code, you're going to see that it's printing out, a bunch of random values. And that's actually not what I intended to show you. I wanted it to error, but so be it. Essentially though, this is going to print out the type, and I can probably maneuver a way to actually show you the type. So just we can write that code real quick. And so the way to do that is we're going to actually use the printf statement. So what we can do is do fmt.printf, and then what we can do is %t. And this is using something called a string substitution, like before. If you remember that from previous lecture, we talked about string substitution at the beginning. So this %T, the %T basically means type. And if I type in the variable, it's going to be grades. If I run this code now, it should, yeah, that's the type. So it's actually going to print out whatever the type was. So if I, put that up there, you'll notice that, it's a slice of integers both times. And if I change this to 3, and then I comment this code out, because you can't append to arrays, you can only append to slices. You notice the type actually contains the index, how many indices the array is allowed to have. That's something pretty cool about Golang. It actually keeps that in the type, and it shows you that. And similarly, if we change these to float 64s, even though you aren't float 64s, but if we change them, it'll show up as well. This is the type of the of this value. So it returns the type that you input. So if you input a slice of strings, it returns a slice of strings. If you input a slice of array or a slice of slices, hypothetically speaking, you could do that. You could actually do a two-dimensional slice and have a slice of more slices. That is completely okay. Maybe I'll talk about that actually, but for now it's a little bit complicated, so I'll skip it. But whatever type you put in here, it's going to give you back. Okay. Thanks for the question. So essentially, I will go ahead and continue on. So what we can discuss now is we can discuss how to actually delete a value. So let's hypothetically say we wanted to delete a value from this array. So I'll delete this code here, or I'll actually just change this code here. And I'll delete this code up here. So now if I run this code once again, it's going to print out our array. Obviously, we do not want to specify the length. We wanted to keep it as a slice. Now when we print this out, it's the array as typical, or the slice as we wanted it. So now what we can do is we can go ahead and say, I want to go discuss how to delete an object from this array. So what if we don't want to have an 88 in a class? Obviously that's not ideal. What we can do is we can type in delete. And if we type in delete, and then let's say grades is the list that we're trying to add, and then we need an index. So the delete function basically takes an index of a slice or a map, but we'll get into that in a second. And then essentially we'll delete that object from that. So if I type in 4, this is actually the third index, sorry, and then I print out grades again. And we may or not get an error, and that's why I want to, it's a good segue into the next topic that I want to talk about. But if we run this code, it says first object to delete must be a map and has a float 64, and that's exactly what I wanted to talk about. Is slices aren't very powerful, especially for what we're doing here. It's not very useful to know that we have a 99, a 92, and a 94 as specified here. What does that actually mean? What classes do we have those grades in, right? It's not helpful knowing that we have a 99 in some class, but we don't know what class, right? It doesn't specify, and there's no way to specify using a slice. A slice is useful for things, like a queue. If you have, a bunch of people in line, you want to be keeping their, their username in the array, or in the array or the slice, however you design your system. So it's not very useful for something like this, and this delete keyword basically shows that there's an object called a map, and that's what I want to get into now, is that we can actually call this map object, and although these map objects are kind of complicated, and they're a bit annoying to work with, they're extremely powerful. So what we can go ahead and do is I'm going to delete this code, and if anyone has an issue with that, let me know. I just want to have a fresh code palette. And if you need to refer to this code later on, obviously the video will be uploaded, within 45 minutes, hopefully, or maybe 2 to 3 hours, because YouTube takes a little bit of time to process the video, but it'll be up as soon as possible if you need to refer back to the code. So we'll go ahead and delete that. Once again, if anyone had an issue with me deleting that, I'll definitely put it back up. But that's just something I wanted to go over. Okay. Thank you. Encoded which? That's a nice username. Okay. So we can go ahead and discuss now these more complicated types called maps. So I'm going to use the very old mechanism to define a variable. So we're going to use the var keyword, the var keyword, and we're going to define the variable as grades. And we're still going to use the grades keyword because it's actually going to be very powerful now in this case. So what we can do is we can actually define it as a map. So the data type, remember, and I'll just do this again just for the sake of this. When we used to have a variable like this, we define this as the variable name, so the variable name would be A, and the type of the variable will be integer. So what is the variable type we want when we're making a map? So we start out just like as if we're writing an array. And when we're writing an array, what we're going to do is we're going to basically write it as we have 2 brackets and then a type. So let's say integers. So, if I run this code, you'll have an issue with FMT, but that's not really an issue. So let me just type, run this code real quick. Grades, if I hit run, there we go. It's an empty array because there's nothing defined, and it's a slice. Whenever I say slice, but there's no actual length here, you can assume it's an array. You can assume it's a slice just because it's jargon, but you'll get used to it. So I might call it an array, I might call it a slice, but there is a difference. So this is one way to do it. However, if you want to actually use a map, what a map basically is, it's going to have a key value pair. Meaning rather than having 99, 91, 92, 90, right? We can say science 99, math 91, chemistry, or no, social studies 92, and I guess Spanish, let's say 90, right? I shouldn't include an English class, but whatever. Essentially, you'll have, you'll actually have a key value pair. So this is a key, and this is a value. This is a key, this is a value, this is a key, and this is a value. So I want to ask you a question. What value, what should the type of the key be? And I want you guys to answer the question. what type of variable will this key be, right? Will it be an integer? Will it be a string? Will it be, it could be another slice? Will it be a float? What type of key, what type of data type will this key be if we're going to specify science, math, social studies, and Spanish? So I want you guys to answer that question. All right, yep, that's exactly correct. It is a string. So to define a string, we're basically going to say string within this this array. So rather than typing, something in it or even a length in it, we're actually just going to type in string. So if we run this code now, it's not exactly going to be perfect. So if we run this code, it's going to say type string is not an expression. That makes complete sense. This used to be, in our old code example, this used to be a number, and the number was the length of this array. So now we're just putting string there. It doesn't really make that much sense. Why are we doing that, right? So rather what we can do is we can type in map. So a map is basically as we expect. On a normal map, when you open a map, like Google Maps or whatever, you have a system of having keys and values, right? So you have a location, and from that location you can see what's there, right? So for example, an address, is located to an object. Or an X on the treasure on a treasure map will point to treasure, for example, right? The key is the X, the value is the actual treasure on a treasure map. Similarly, in this, you'll actually have keys pointing to values. So if we run this code now, you'll notice that now the data type, or it's printing out a map, and that's because there's nothing in here. So what we can do now is we can say, let's say, rather than typing in. So previously we used to do this. So I'll do this for the sake of the example. So grades 99, grades 1 equals 92, and grades 2 equals 89. So I'm only specifying 3 for the sake of this. Now, if I run this code, you're going to notice that it says cannot use 0, cannot use 1, and cannot use 2. And it says it's type of untyped integer, and it says as type string in map index. So can anyone think of an issue that we might be running into? Why is it saying that it can't use an integer as a string in the map index? So I'll give you about 5-10 seconds if anyone actually wants to type that answer out. Otherwise, just think it in your mind for the sake of comprehension of what we're doing here. Okay, so essentially what we're doing here is we're saying that we're trying to put, wrong literal, exactly. So what we're doing here is we're trying to say 0, 1, and 2, which are, data types of integer. However, we're asking for the keys to be strings. And this is going to make a lot more sense in a second, right? And I'm going to define one more variable, actually. I'm changing these values because I wanted to correspond with these. So rather than using an integer, like we're using here, what we can actually change this is the actual key. So if I change this to science, if I change this to math, if I change this to social studies, and if I change this to Spanish, you'll notice that now we're basically saying that the value of we're indexing using a string. So this science is now part of the string, this math is part of the string, social studies is part of the string, and Spanish is part of this is a string. And these are the keys of our map, and the values of the map are correspondingly 99, 91, 92, and 90. So if I run this code now, assignment to entry. And that's one of the issues, actually. So because of how maps work, we actually want to introduce the walrus-esque syntax, or the assignment syntax. So rather than, and I recommend this when you're using it in your day-to-day life, if you ever use Golang, or if you use Golang in a production environment, you should let Golang, you should actually be using this this colon equals operator. So rather than saying grades is like that, we're going to say grades is equal to, and then we're going to say map string int as we want. So I'll just remove this code here. And now if I run this code, we're going to get an issue. It's going to say type map string int is not an expression. And this is the same error that we got before. This error is basically saying that, the type, that this doesn't actually define any value. Remember, when we used to define variables like this actually defines some value. However, this actually defines some value. It's an integer and it has a value of 5. However, this is only a data type. It doesn't actually have any value. right? So what we want to do is we want to use a function that's built into Golang, and this Golang function is called a make function. So if I surround this value by make, what this is going to do, it's going to basically say that, hey, Golang, I want you to make a variable container for me. So what we're basically going to say is map string and int, and then we're going to make that. And what that means is we're basically going to predefine and initialize it as something that's empty. And so if we run this code now, you're going to notice that we have a map. It has a math of 91, science 99, social studies 92, and Spanish of 90. And keep in mind, the order is not meant to be, the order doesn't mean anything to us, actually. This is actually an alphabetical order. This is math for science SC, social studies SO, and then Spanish SP. So it's now actually doing it as intentionally, and for some reason REPL is reloading, but we're doing this intentionally that it doesn't matter what the order is. However, now we're able to see that math has a value of 91, rather than arbitrarily saying that that one of the grades was 91, one of the grades was 99, etc. And Golang was really having some fun here, so let me refresh this real quick. And I'll run this one more time just to show. Remember, there's no longer arbitrary values. They're actually defined to something. And we can similarly index like this would be a normal array or slice. If we want to get the science grade specifically, we can run grades science. And now this is saying, the grade is 99. Previously this would have we would have only used a array like an index, grades index 0. This is going to get an error, and because 0 is not actually an index of this, because 0 is a string, and you're not allowed to index this this map using 0 is an integer, and you're not allowed to index this map using integers. You have to use strings, and there is no index 0 defined. What we could do is, as a thought experiment, we can actually define a string integer, a string index, with a string, like the literal string 0. So rather than the number 0, it's the string 0. And I can say that's a value of 90. If I run this code, once again an issue. But if I change this and I surround this with quotes, and if I hit run, you'll also notice now this prints out a value as intended, and I can actually remove this end bit here. And if I run this code, you'll see that 0 is one of the indexes. So it says 0:90, math :91, science 99, etc., etc. Yeah, and that's just, one of the things. If I change this to an integer, then what we could do is we could say that this is 0. And if I run this code, now we're going to get an error with every single other, element. So if I change these, and I run this code, we'll get a map of 0 to 90. So, obviously this is kind of useless. However, you can index, you can change this to whatever you want. You can index with strings, integers, floats, whatever you may want. And then you have integer. And a practical example of this is, hypothetically, let's say you had a map of all the people on Instagram, right? And all of the indices, rather than having their username, you had an integer 64. So let's say int 64. And an integer 64 is a very large number. It's a 64-bit number. I believe it goes to 9 trillion or something. I'm not entirely sure. It's a very large number, essentially. It's 2 to the 64, whatever that might be. And so let's say that's your index, and then your value at the other side, this resultant value that you want as a value. So your keys are int64, and your values are integers. So let's maybe say that your int64 is actually the user IDs of all the people on Instagram. So rather than showing the username, you show their actual user ID. Because every username on Instagram or every profile on Instagram actually has a number attached to it, and that's just how Instagram works, for example. You can also change this to strings, and now you could actually put the usernames as the keys. And then on the other side, you'll use an integer, and this integer will be used to actually define how many followers they have. And this is just one example of how you could use this. Obviously, that's not how Instagram is built. They use a more complex data type. However, this is one of the ways you can define the keys and values. The keys could be usernames, and all the values could be how many followers you have, or what your password is. Obviously, that's not good practice, but you could do a lot of powerful things with that. So if you have any questions about the practical uses of maps, you can obviously let me know. These are actually very much like they're very much like dictionaries in Python. So dictionaries in Python will have a key and a value. Similarly, we'll have keys and values in grades, just like that. So we can get rid of some of this code because most of it, and actually the only thing I want to add to this is we're gonna make sure that all of this is good. We're gonna delete this value here, and I'll uncomment all these lines. So all these lines are back in. If I run this code, we'll get back to what we want. So what we can do is we already know that we can, if we want to delete Spanish, we could delete Spanish. If we wanted to index Spanish, I'll do that for you right now. We can index Spanish just like that. When we index Spanish, it'll say 90, etc. So what I can do is basically I can say, if I wanted to delete a value from this array, what I could do is I could say, I could use the delete function. This is what we tried to use on a slice, but it didn't work because this delete doesn't work on a slice. It only works on maps, and this is how I segued into maps. So we can say the delete function, and then we can pass in grades as the map that we want to delete from, and we want to delete some index. So let's say we dropped out of Spanish. It doesn't matter what our Spanish grade is anymore, so we can type in Spanish. So I'll copy this code here. So if I run this code like this, now you'll notice that you first print out math, science, social studies, and Spanish on your first line, on your first print statement. But then after you delete the Spanish grade, you only have math, science, and social studies because you've deleted Spanish, right? You've dropped out of Spanish, no longer there. So then you've deleted that index from this map. Okay. So if you have any questions, I'll give you like a couple seconds, minutes, like maybe about 60 seconds to get that. If there are any questions, that is. Okay, so I'll go ahead and move on. You guys are a smart bunch, so you guys don't have any questions. It's kind of cool. So we can move on to how to define a for loop. And what we can do is let's say I want to make and what a for loop is, it's an iteration. It's a system of iterations. So I'm going to delete this code again. If any of you guys have an issue with that, let me know. And I'm just going to define some numbers. So let's say nums equals a int array or int slice. And the values are going to be, 16, 15, 11, 8, 7, and 3, for example. If we print out this array, you can obviously print out the nums array. You print this out, you see all these values, nothing special there. We're not doing anything special yet, right? So what we can do is one of the powerful things about how we can manage arrays or for loops is actually, we're actually going to ignore this slice for a second. We're going to talk about, what a for loop is. So you can define a for loop by just typing the for, like the keyword, the for keyword, and then you need to write some code here. So what we can do is we can say some arbitrary value, some arbitrary variable, and we want to give this an initial value of something. So let me build up the example of, let's say I want to iterate the values of 0 to 4. So it's going to print out 0, 1, 2, 3, and 4. Right? What I could do is I could type in, fmt.println 0, and then fmt.println 4. And obviously I'd have to fill these in, so I'd have to do 1, 2, and 3. I'm just not going to write the code for that, because I don't want to. So what I can do instead is I can actually say some syntax here. So first you're going to actually write 3 statements in this for loop, and it's very similar to other languages, but you're going to write 3 statements here. First, you're going to actually assign and declare a variable. So we're going to use the variable I. I is commonly used, conventionally speaking, because it's a I for index, or I stands for index. So, you know, I is equal to 0, then, you know, I is less than 5, and then we're actually using semicolons. This is one of the only cases where you use semicolons in Golang. We're using semicolons to separate this. So the second one is going to be a comparison operator. When am I going to stop looping? Right? That's the question you want to ask. You know, I'm eventually going to stop looping, but when am I going to stop looping? This is how we tell the for loop. You're going to stop looping when I becomes less than 5. So when that becomes true, stop looping. Or sorry. When that becomes false, stop looping. So, you know, on the first iteration, I is 0. So is 0 less than 5? Obviously 0 is less than 5. This is true, meaning evaluates the code. If, you know, then as you go on, if I becomes 5, is 5 less than 5? No, 5 is not less than 5. As a result, the code stops executing, right? And then finally, you need to write some type of statement saying what's going to happen after one iteration runs. What we're going to do is we're going to basically write I plus equals 1. And remember we talked about complex operators here? Another way we can do a complex operator is, see, what I can do here is basically say, you know, I equals I plus 1. That's one way to do it. Another way to do it is I plus equals 1. And the final way to do it is if incrementation is only by 1, you can say I plus plus. I plus plus basically just adds one value, it increments the value, and it's very useful for loops like this. So we're just going to say I plus plus, okay? And I'm going to print out the value of I as we loop, okay? So if I run this code now, very simply speaking, it's going to print out 0, 1, 2, 3, and 4. Exactly like this would have printed out, except now, you know, let's say we wanted to print out all the way to 100. We do not want to write those statements manually. That would be that would be hell. So this prints 0 to 99 exactly as intended. And remember, why is it not printing out 100? Well, notice that when we get all the way down to 99, it's going to say, you know, I is 99, 99 is less than 100, and then when this code runs, increment I by 1. So, you know, this runs and it prints at 99. It goes to the top. It says, okay, what am I going to do after that? It's going to say, now I has a value of 100. So I is equal to 100. Is 100 less than 100? No, I is not less than 100. Therefore, it's not going to do anything. And this code will, you know, you'll move on to the next, you know, line. So let's say, done with the for loop. If I run this code now, it'll say done with the for loop at the bottom. As you know, obviously this is pretty normal, like as you'd expect. If you have any questions, let me know. But pretty self-explanatory. Another thing we can do with the for loops is we can actually treat them as just arrays, so as while loops. So if you remember, you know, languages like some languages have like implicit ways. Can you exclude the parts of the for like? Yes, you can. So an example would be, and this is actually what I'm talking about. Basically, you can treat a for loop like a while loop. So for example, in this code, what we can say is rather than saying, you know, I is equal to 0. So let's define I is equal to 0 here. Since I is already defined, we don't actually need to write this code here. So we can, and that code's called the instantiation part of the for loop. We no longer need to write it. So we can actually put that on line 20. Now what we need to do is we can basically say the operation. So any of this code will run, you know, after each other. So the only thing we actually need in a for loop for it to keep running is this I value. So for example, if I say I is less than 100 and then I plus plus, even though we remove this code from this for loop, it will still run, you know, 0 to 99. Actually, no. Sorry. If you're gonna use this type of for loop, you're actually gonna have to remove the incrementer as well. So if I remove the incrementer, we're gonna get a little bit of an issue. It's never gonna stop. It's also never gonna change the value. Okay? So it's always going to be printing out 0, you know, infinitely, and you can see my scroll bar is like, you know, it keeps printing out. So I'm going to hit stop on the code, terminate the program. What I can do is I can actually just say I plus plus at the end of this code, and now when I run this code, you'll keep noticing that it's going to go all the way until, you know, it's going to go 0 to 99. So what if we want to do forever? We can change this value to a Boolean, so for true. So while this is true, it's going to keep printing it out, and, you know, it's printing it out, keeps printing it out. It's never going to stop. There is no condition for it to stop. So I can write my own condition, you know, I is less than 500. And then I say, boom, you know, It goes all the way from 0 to 499. Obviously, it's less than 500. And I can also say I is less than or equal to 500. And it's going to go all the way exactly and including 500. So you can exclude a lot of things, and this is how you treat it as a for loop, as a while loop. Seems like 2 people are typing, so I'll move on after that. This is a for loop. Sure, that's actually a great example, great question. For each, there is a for each, and that's actually what I'm about to get to, and that's what the homework's actually going to be about, to an extent. And the homework's going to have multiple questions, though, but, it's to an extent. So what could be a practical example of that type of for loop? So in the practical world, let's say you need to run something, forever. Let's say listeners is one example, yes. You can keep running things and, listen on. Another thing is, hypothetically speaking, let's say you need to randomize. Let's say you have an array of 10 numbers, and you're trying to add, and someone's asking you to add an 11th number on. However, that number has to be both random and unique. So you can't just pick any random number, and the number, you have to pick a random number, but you can't do that, just by looking at the array and adding the number yourself. You have to use code to do it. And let's say you want the value to be unique. Well, what you could do is you could write some code that basically is and I'll write the pseudocode for this. So let's say you have some array, so some nums equals, and I'm writing the pseudocode. This is not actually Golang code. This is just some code, okay? And that's let's say 21. So let's say you have these numbers, okay? So 1, 21, 6, 363, 2, 6, and 162, and 62. These are completely random numbers, obviously. What you could do is you could write an infinite for loop. So for, and we can say, var is unique bool. And then we can say for is unique, and we're gonna instantiate this to false as by default. And what we're gonna say is we can say if for is unique, and then we can say, num equals generate num, let's say some random variable function. And then we're going to basically do a check. If num in is unique, then we can say that num equals nums equals append nums num. And then we'll say that is unique equals true. So generally speaking, what this code is going to do, and I'm apologize if this is a bit too fast, and we're going to go a little bit over the 3 p.m. Deadline, but that's okay, or 3 p.m. local time, whatever minute it turns in 2 minutes for your time zone. We're going to have this nums array, and basically these are the numbers that we already have, and let's say these could be user IDs. We want to have unique user IDs, and we always want to have unique user IDs. So we want to pick a value that doesn't already exist. We're going to define a variable called isUnique, and we're going to say that it's a Boolean. A Boolean value is true or false, and we're going to by default say it's false. And then we're going to say it's that's a very bad example, sorry. So we're going to actually make a Boolean value called unique met, and we're going to say this is true and this is false. And just bear with me, basically. So what we're going to say is that we haven't, when this is true, we haven't met the unique value. And, I should actually specify that not unique. So by default, we're going to assume that it's not unique, and we're going to call the variable true. So while it's this says for not unique, but another way to interpret it says while it's not unique, I want you to keep looping over this value, over this code block. So these 4 lines of code will keep running until this not unique value is going to turn false. So we're going to generate a number for every single iteration. If num not unique, if the number is no longer unique, meaning, if num not in num, so if the number that we've generated randomly isn't in this array, which is what we want it to be a unique value, meaning it can't already be in the array. If that's the case, we're going to append the number onto the nums array, and then we're going to say not unique equals false. So by saying not unique equals false, we're basically telling this array that, hey, it's now unique, you don't need to continue. So on the next iteration of this loop, when you say not unique, it goes up and up and up back to line 29, and it's going to say, hey, this is false, we're no longer going to run the program, we've successfully created a unique number in the array. Okay? That's just a practical example of what we're doing here. So that's where you could use this type of for loop. So I'll just keep this code here, in case you're curious. But that's how we do a for loop. And the last thing we want to talk about will take about 10 minutes, maybe less, is, I'll move up here, actually, I'll let the code up here. And remember, if you need the code from before that I wrote, it's always going to be on the YouTube video that we're going to release in a couple hours after this lecture. So if we want to run through these values, through these numbers, what we could do is the practical example of this is, let's say I'm going to define this has 6 values. It has 6 integers. It has 1, 2, 3, 4, 5, 6. So it has a value of 6. And I'm defining a max length just for the sake of this. What I could do is I could say for I equals 0, and I'll comment out this code here. For I equals 0, I is less than 6, I plus plus, I could actually print out, I could print out I. That wouldn't really do me any good. If I run this code, it's going to print out 0 to 5. Doesn't really do much. However, what I could do is, since it's printing at 0 to 5, I could also just say nums, and then use this as an index. So on the first iteration, it'll print nums of 0, nums of 1, etc., etc. So if I run this code now, you'll notice that it's now no longer printing out 0 to 5. It's printing out the first value, the second value, the third value, fourth value, fifth value, etc. That's the 0th value, first value, etc. But you get my point. So it prints out these values, and that's how you iterate over an array. That's one example of iteration over array. However, that's not really efficient. That means you have to find the length of the array, and you could find the length of the array using nums.length. And if you run this code, I definitely butchered something here. I've completely gone blank on what the length array is. So I'll just delete the code for now. But essentially, you could find the length of the array. For some reason, the function name is this is why Stack Overflow exists. I completely forgot the function name. However, you could find the actual length of the array, and you could do this so that even if this was a different length array, it would still work. However, what we want to do instead is we want to say a different method of using that. So we want to basically be able to iterate over this array. And it's actually very simple. So what we can do is basically we can say that we want to iterate over the array. So we're going to write some code. So we're going to use the for keyword once again. And then what we're going to say is we're going to do for index value. So let me just write the rest of the code. I can explain after. So now if I run this code, and what this is going to do is real quick, I'll run the code just to show you. I'm not sure where I did that. There we go. So now if I run this code, it's going to print out, index 0 is 16, index 1 is 15, index 2 is 11, etc., etc. And it prints out every single value in every single index. So what we're doing is we're basically, and you can read this in pseudocode form as for index and value in the range of numbers, of nums. So this is saying that we're going to print the index and value. They're going to find the index and value of each of these numbers. So in this array here, and I can train this back into a slice now. It doesn't need to be anything else. Even before it didn't have to be an array. I could have done that as a slice. However, for the sake of knowing the length, I did that. So what we're doing now is we're saying for index and value. So this is the index, so the index position you're at, and then the next part is going to be value, so that the value is each value in the array. So 16, 15, 11, etc. And that's going to be in and the code's loading. Okay, not sure why that's happening. I'll refresh this code. And to answer your question, Raiku, yes. When you do type in, and keep in mind that has to be a lowercase l in the fmt.println. When you do this, fmt.println, each of these, every time you use a comma, it's automatically separated with a space. And that's why when you run this code here, there's a space in between all these values. So this is some string formatting. But essentially, what we look at this doing is basically it says, take this array, or take the slice nums, and I'm not sure why REPL's having an issue right now. We're taking the slice nums, and we're saying, for this, we're going to say the index is whatever index you're at, and the value is whatever value you're at. And you can print out these values and just like that. So what I want to go back to is why I probably shouldn't have deleted my old code, but we can figure that out. You can use a different type of string concatenation, and there is a separator method, Raiku. I can help you with your question after the lecture. So what we can write here is, rather than typing in nums, we can say grades map, the index can be like this, and then grades, let's say Spanish equals 99, grades of science equals 91, grades of math equals 100. Okay, so rather than saying nums here, we can say grades. And since this is a map, right? What is a map, notable for? The index is not actually the index. The index is going to be the k. That's fine. That's CA encoded which. So the index is going to be the key rather than a number of where it is, like 0, 1, 2, 3, 4, 5. It's going to be the key of what it's stored as, and the value is now going to be the actual value of the grade. So if we run this code now, it's going to print out the index of Spanish and the value of 99, science is 91, and math is 100. Which is, pretty intuitive. This is what we expected. And then also what we could do is we can change some things, like for conventional reasons, we could say key, and we could say key is here as well. And if I run this code now, you'll notice that it prints out the same exact thing as before. So this is how you use it with a map instead. And that's actually all I have left for the lecture. That's all I have for the lecture this week. It's pretty simple. And you can do a lot of things here. For example, one task I could assign you guys to do, and this is going to be the homework, one of the homework questions, is I could say that, and real quick, I'll just do this. So let's say we have a num slice, and, there's, let's say, 1, 2, 3 values in it. And I want you to, the task could be iterate, or I want you to append numbers 0 to 10 into nums, such that nums is so it's going to be one of your homework tasks. This will be in the homework assignment, the PDF. But essentially, I want you to append numbers 0 to 10 into this array using a for loop. I do not want you to use, the actual, I don't want you to do this 10 times. Because I know you can do this. That's very easy. So this is technically a solution. I'm not even going to bother typing the rest of that out. That would be, that's a little bit annoying to do. So we're not going to do that. Sorry. We're going to ask you to basically just use a for loop that's iterating over, 0 to 10, and make sure this is your end result. And, you can define this, you can initialize this variable however you want. That's up to you. So go ahead and, try that. The rest of the homework will be assigned in a little bit, a couple hours maybe. And if you guys have any other questions, of course, feel free to ask me. Don't hesitate. And, of course, I appreciate you guys joining this Code the Universe Foundation lecture for Golang. And I will see you next week.